All right, so yeah, I didn't record the first part of the lecture, so I'm just gonna quickly recap what we did. Um, so first, we wanted to design a design a relationship, basically relationship hierarchy for a particular application. Say we're trying to model employees at at a software company. So we have the most general case of an employee. An employee is going to have anything that any employee would have, like maybe an employee ID number or a key card or a starting salary or something like that. And then as you get more specific kinds of employees, you have technical, like the technical track. So a technical employee is an employee, a manager is also an employee, and then a front end developer is a technical employee, which is an employee, and so on. So you diagram this out because keeping track of it all in your head is difficult, and why not make it easier on yourself? So we're drawing it out, and then when we actually go to implement it, um, here's the implementation we have so far, which is basically as simple as possible. We just care about the relationships at this point, so everything is just passed. And then we also wrote unit tests here, and the unit tests are uh, right now we only care about the structure. So we're just making sure that the inheritance hierarchy is correct. It reflects what we diagrammed out. Any questions about that so far? Okay. All right. So now let's go ahead and try to add some actual methods here. So we said that employee is going to have a key card. So how can we make sure that an employee has a key card, key card ID or something like that? You can do def init. So anything that you want this instance to get when you create an instance of it, um, you can call. So init is basically a hook. So we mentioned hooks before. So init, you could think of it as a hook. So there's a certain life cycle when you create an instance of an employee, and init is part of that life cycle. So you can hook into that and then do stuff. So in this case, everything has to have self, and then we want a key card, say key card number or something. So self dot key card number equals key card number. Okay, so now employee has a key card number. So does project manager also have a key card number? Well, let's write a test. So project manager, let's just say we want to check project manager. So we check that it's an instance of employee, and now we also want to check self dot assert is actually, so how could we write this? There's a couple ways we could do it. One is we could check if it's like not none or something like that. But really, we want to kind of want to check that it doesn't throw an error if you try to access it. Um, so you could potentially just try and access it, and if it does fail, it will throw an error. You could do. Hmm. Yeah, maybe to make this clear, we'll just check if it has if it's not none. So self dot assert is not none. PM dot keycard number. All right, so now I'm going to run the tests, and all of the tests failed now. So why are they failing? Let's look at the first one. So another thing is the tests don't necessarily run in order. So they be aware of. So test employee. So why does test employee fail?
I think now they all require assigning a key card number when you create the instance.
Yeah, exactly. And we get what kind of error? Type error. So let's go Python. Let's see what the inheritance hierarchy for type error is. So we can go type error dot mro. We can see that type error, it inherits from what? Exception, which inherits from base exception, which inherits from object. So this is a built-in Python error, but it has its own class hierarchy. So the exceptions, exceptions have a base exception, then exception, and then all kinds of specific ones. And you can create your own custom exceptions that also inherit from exception. Okay, so how do we fix this problem?
Just for each like for online 8 in those parentheses, put the key card value parameter. And do that for the other tests like M, T, and D.
Okay, so let's run this this first and see if it passed. So we only have 5 errors, so one of the tests passed. Looks like that first test passed. And what happens if we add this to all of them? Let's add it to this one. So I'll just run these 2 tests. I'll comment these out for now. Okay, so this test still fails. Why did it try to run 3 tests? Oh, okay. This. Okay. So this test does it does actually pass. And what do you think the value? So let's write another test. So self dot assert equal m dot key card number is 1, 2, 3, 8. Okay. Let me just I don't think this should this should be passing. Let's see. So test manager, I'm gonna comment this out real quick. Interesting. Okay, so it must be implicitly using the init of its superclass. Okay, that's fine. Let's go ahead and make manager more specific now. So a manager is now going to have init. So manager needs to have, let's say, a department. So self.department equals department. Oops. All right, so now I'm going to run these tests. And now I get this issue where manager doesn't have a key card number. So we have this problem where manager needs its own init, right? It needs its own custom init because it's got its own manager specific stuff we need to give it. But it also needs what's in the employees init. So when we do this, we actually we're overriding this this init here. So let me show you another example of that real quick. So if I do def so show up. All right, so I'm gonna create an instance of employee. I do e dot show up. So we get I'm here. So that makes sense. And now if I do m equals, actually, let's do it a different one. We'll do technical. Def show. Actually, first we'll do as is. All right, so now we're going to create an instance of technical. And what do you think is going to happen if I call technical show up method?
It's gonna fail.
Okay, so why is it going to fail if I call show up on technical?
Because you're not inheriting employee yet.
Okay, so we're kind of putting a pause on the manager stuff for now, and we're just looking at employee and technical. So I just created a method called show up an employee, and we just tested it, and that works. So we can create an instance of employee and call show up. Then what I did is I created an instance of technical, and now I want to call show up on technical. So the question is it going to fail or succeed, or what's going to happen?
Should just say show up. If you haven't overwritten it, then it would be part of the inherited, from the employee class.
Okay. Okay, so let's try this out and see what happens. Okay, so we have to pass in a key card number. And it looks like it works, and it's the exact same thing. So what's actually happened here is that because technical inherits from employee, it gets all of this stuff for free. So when I create an instance of technical and I call show up, it's gonna first look here. It's gonna look at the MRO, right? It's gonna look in the order. First, it's gonna try the actual instance itself and say, hey, I want to call show up. Do you have show up? The answer is no, but I inherit from employee, so you can check employee and see if employee has show up. So it does that, it finds it, and then calls it. Now, if I do this, now what's going to happen? If I call create an instance of technical and call show up.
It's gonna override employees show up method.
Yeah, so what does it mean when something overrides something?
Like the hierarchy, because you're calling an instance of technical, it's going to use that that method rather than like the base class or where it's inherited from.
Yeah, so let's call this and see what happens. So the instance of employee gets the employees show up, and the instance of technical gets the technical version of show up. But notice that it stops here, right? So when I say, hey, instance of technical, call show up, it finds it and then stops. It doesn't just keep looking for, it doesn't keep going up the hierarchy, right? It stops as soon as it finds something. So this is basically shadowing this now. Okay, so now if I have manager and I create this init method, this init method is now shadowing this one. So this one is going to get called and this one isn't going to get called. And in the same way that when we call technical show up, this might as well not exist. But we need this stuff. So we need to call the init method of this employee class. So how can we do that? Let's do it right here first. So I want to call not only the technical method, but I will also want to call it the employees version. So I can actually do employee dot dot show up. And you see that I'm here gets printed out twice because this employee actually calls this one. So we can do the same, we can actually do the same thing in the init method as well. So we want to call the employees init method. So we can do employee dot init. And then anything, what do we need to pass into the employees init method?
Key card number.
Yeah. So we're gonna have to adjust this as well. So it's gonna need a key card number. So you know, like what did I just do? So when I call the init, I also need to pass in key card number. Now, if I try to run this, actually manager should, yeah, okay. So I need to create an instance of manager now. So I'm gonna comment these out. And I'm gonna create an instance of manager. And what do I have to pass in to manager?
Key card and department.
Yeah, exactly. So, and then department. If I run this, it should not fail. It's not gonna do anything but not fail. So now let's write a test that reflects what we're expecting here. So we know that manager is going to need two things now. It's going to need a key card number and then also a department. So let's say API team. And let's run the test, Python test employees. So this test now passes. So let's comment this one back in. And we can add another test. We can say that self.assert equal m dot what do you call it, department API team. So as you can see, a lot of these tests are like, they seem a little silly, but since we're kind of just testing we're testing the basic structure here. So key card number is coming from this employee instance. Okay, so let's comment in this guy again. And run that. And that test is going to fail. So technical fails. Why does it fail? Because I'm trying to create an instance of technical, which you can see right here. And it's telling me that the employee in it is missing one required positional argument. So why is the error? Why is the error that the employee in it is missing an argument when I'm creating an instance of technical?
Do you not have an ID number for the technical employee?
Yeah, you need the key card number. So technical is going to use employees init method by default. So that's why the error is actually coming from the employee init, because that's what's being called when you create an instance of technical. So we just need to pass in whatever this is, 123 ASD. And if you write this test, that should pass. So now let's do the same thing with developer. Okay, so let's go to developer, and let's say developer needs languages. So def init. And we do self.languages equals languages. Okay. Is this gonna work? Let's see if it works. So we got developer, and I'll pass it some languages. So this will be Java. And this test does actually pass, and let's check what we got here. So self.assert equal d dot languages equals, oops. And I'll copy this. And then let me check the dot key card number. And that would be let's just say 1, 2, 3. Okay, so we get an interesting error. We need developer to have a key card number, otherwise the developer can't get into the office, right? But what we did here is when we have developer, we overrode the init method. So now a developer only has languages. It doesn't have a key card number. So how do we make sure that a developer has a key card number? Where's the key card number going to come from?
Employee.
Yeah. So we're going to have to call the employees init method. So basically the same thing we did here with manager. And then we're also going to need key card.
Would that be the same thing as using the super built-in function?
Yes, yeah. It is the same thing. I'm not using super here for a couple reasons. One, it gets trickier when we get to the end. And two, I just want to like kind of show the concept clearly that we're specifically calling specific things in a hierarchy. But yeah, you're right. So you are going to see super here, and super would work fine. So super is basically just a reference. It's a little more complicated than this, but it's basically a reference to the parent class or to the parent class hierarchy.
Todd, would you mind splitting your screen on the employee and test?
Yes.
Thank you.
Okay, so we've got a developer. So we're looking at developer. So developer needs to have a key card, right? It also needs to have languages. And in order to get the key card from technical, which actually is going to get it from employee, so we're going up 2 levels here. Since neither one of these are overriding the init, it's going to find the init and it's going to look for an init in all throughout the hierarchy. It's going to find it in employee and use that one. We can short circuit that and just call it directly here with employee. So we're going to make sure that the developer has a key card number, and also it has languages.
I have a question
Yeah.
about, I know we're not using super right now, but if you were to use super, like on line 27 instead of employee,
Yeah.
does it just start at, I guess, technical and then go up the MRO until it finds another init to run?
Yeah, I think there's a few peculiar things about super, but that's basically what happens. Yeah. So you can call super init and then pass in key card number. So this should work exactly the same. Yeah, I think there's an issue where once you use super, you have to use super everywhere. So I'd have to go in technical and also make sure that, let's see, well, that should be fine actually. Developer init missing one. Let me see. If I need to pass in, I might need to pass in self. Forget.
I think it's in the test file on line 22. You need to add in a key card now.
Right. Oh, yes. Thank you. So this needs. So you could use super here. It gets more complicated. There are ways to use super when you have multiple inheritance and they all have different inits. But it requires a little bit more work, which I don't want to. I kind of just want to focus on the structure here. So we use this. Okay, so now let's test the project manager. I don't think we changed that, so let's see if this passes. And it's missing 2. It needs a key card number and a department. So we'll add those here. Okay, so now we get to the final bit where we have multiple inheritance. So let's say we want a head engineer to, I don't know. What should a head engineer have? We'll just say a degree, even though you definitely don't need a degree, but we'll, so self dot degree equals degree. All right, so now if we try to run the tests, okay, head engineer init is missing 1 positional argument, degree. So I can pass this in. CS. Okay, those pass, but does the head engineer have, can the head engineer get into the office? Let's see. HE dot key card number. An error, head engineer object has no attribute key card number. So why doesn't head engineer have key card number?
It was never, it's not in the init, so you gotta define it with the kind of how it did employee.init.
Yeah.
Right
So,
under the third line 32.
Yep. So we're overwriting the init right here. So head engineer has its own init, which is overwriting it. So none of the other inits of developer or project manager are going to get called. So that's why head engineer is not getting that stuff. So what do we have to? We need to make sure we can handle the developer init. So developer dot init, and this is going to take what? Self and something. What does the developer need? It needs a key card number and languages. And then we have to handle the project managers init. And what does that need? Project manager, I don't think needs anything in particular, but it inherits from manager. And what does manager need? It needs a key card number and a department. Okay, so we kind of know what is required in the init. So now we have to modify the parameters that this takes. So it needs a key card. And it needs languages and department. Okay, so if we go back here, so it needs a key card number. it needs languages, second one. So we'll just say JavaScript, and then department is going to be the C-suite or something, and then the degree will be CS degree. All right, so let's see if these tests pass. So that passes. We can write more tests to make sure that these specific other properties match, but I think that's a basic idea for now. So, at the end of the day, it's all basically just looking stuff up. So if I have a manager is basically a bunch of stuff that manager has directly, and then also everything that employee has. So if I ask manager for something, it's going to check in itself first, and if it doesn't find it, then it's going to check in employee. And if it still doesn't find it, it's going to check in object. If it doesn't find it there, then it's going to throw an error. But it's basically, you're basically just, I have myself, and then you can also check my parent. And the lookup will stop as soon as it finds something. So it's gonna start here, and if we have a method, for example, like show up, which is here, if technical has its own show up, it's gonna stop. It's not gonna keep looking and keep calling every single parent that has a show up method. It's just gonna call it right there and stop. So if employee has show up and technical has show up, and you call technical show up, this is going to get called, and this one is going to be ignored. Whereas if project manager, you call show up on project manager, it's going to have to look all the way up to employee to find it and call it. And the same thing happens with the init methods. If you have an init and you overwrite it, and you want to use the stuff that's in the init of a parent class, then you have to explicitly call that init method. Okay. Any questions about this? Okay. So yeah, this is definitely, kind of complicated. So you certainly don't need to make things this complicated. This is more just to kind of expose you to the potential stuff that you might see. But when you're actually making your own things, you definitely don't need to go that far. All right, I'm gonna stop the recording.